And before I forget, I think we had said that we have a class tomorrow. I wish to request that we take it to the other Saturday. Yeah, I've just realized one of my children has a parents' meeting to attend. Yeah. So let's push it to the other Saturday. Okay. All right, so this diagram is already drawn. So below the diagram, you are supposed to say tutaandika computation of EMV. Computation of EMV at node. Computation of EMV at node. At node. So we start with node 1. We start with node 1. Now node 1 is this one. This is what we had called number 1. Now what you do, you look at the kind of lines that are going out. And I told you these lines are complete. They represent outcomes. And these lines that are incomplete, they represent what we call options. Sasa, if these are outcomes, you multiply their probabilities with the payoffs. Like this. 0.1 times 70 plus 0.3 times 40 plus 0. Our probabilities were different. The probabilities that we had. Sorry, so our probabilities were different than this one. So these ones were different. I have to redo them again. Up to that point. And it's a very equal 0.7. Okay, 7 to 1. 7 to 1. Then the other one was 0.136. Okay, good. So we do the same. So the same one is 0.7 multiplied by 7 plus 0.2 multiplied by 40 plus 0.1 multiplied by 15. And before you write the answer, you check which line is coming in. This line, an incomplete one, is coming in and it has a cost of 20. So that 20 should be subtracted. So you say minus 20. So give me the answer. And those who are online, make sure you're also sending your answers. That 8.5. That 8.5. Let us go to number 2. Let us go to number 2 and do the same thing. So number 2, it is 0.7 multiplied by 40 plus 0.2 multiplied by 30 plus 0.1 multiplied by 25. Then you minus this cost that is coming in 10. $6.5. We go to number 3. Number 3, we do the same thing. 0.7 multiplied by 30 plus 0.2 multiplied by 20 plus 0.1 multiplied by 25 minus the cost that is coming in of 7. So are you able to do the same for number 4, 5, 6, 7, 8? Yeah, so quickly do that. I get the answers. Should be through.
Annual is 20.5.
20.5.
The total is 18.
18. The fifth one.
17.
17. The sixth.
25.
Okay. 15.5. 20.5. That is for number 8.
Yes.
Okay, 16.5. Okay. So that is what happens when you're dealing with that kind of those kind of lines. Let's go to number 9. Now, when you look at number 9 here, you can see the lines going out. They are incomplete. So if the lines are incomplete, what we do, we select. So we are going to say it is the highest EMV. It is the highest EMV at where those lines are going. 1, 2, and 3. Where those lines are going, 1, 2, 3. So in 1, 2, 3, the highest is this one. This one of 38. So we put it 38.5. We put 38.5. And when you put 38.5, you come to your diagram here. You tell us your 38 imechukuliwa kwa number 1. So you mark that. Mark your diagram that way. We go to number 10. Number 10, we do the same thing. You can see there are 2 lines that are moving out here. So we are going to talk of the higher EMV at where those 2 lines are going. That is 4 and 5. So 4 and 5 is this one and this one. So the higher of those is 18. The higher of those 2 is 18. Now here 18 imechukuliwa kwa number 4. So it is here. You mark that. That 18 has been found at number 4. Let's go to number 11. Number 11, the same scenario. So we are going to talk of the highest. We are going to talk of the highest EMV at number 6, 7, and 8. Number 6, 7, and 8. Where we have those numbers, 6, 7, 8, the highest is this one, 20.5. And that 20.5 has been found in number 7. So we again come here and recommend expand. We come here and we recommend expand. So, we go to number 12. In number 12, you can see the lines that are going out, they are complete. So it's a case of multiplication. So it will be 0.4 multiplied by what we have in number 9, 38.5, plus 0.6 multiplied by what we have in number 10, that is 18. Then you subtract the cost that is coming in, this one, 2. So do that and give me the answer. 24.2. With that, we now proceed to number 13. In number 13, you can see the lines going out again are incomplete. This is a matter of selection. So we are going to talk of the higher EMV at 11 and 12. 11 and 12. 11 and 12. So 11 and 12, the higher is this one, 24.2. So that's 24.2, which grew up on number 12. So you mark here easily. So with that now, you can tell us the decision or the advice. The advice that we are going to give now that we are through with those workings. So the advice is already provided here. And you're going to write this. Undertake a survey. Undertake a survey. Undertake a survey. And if the outcome is acceptable, build a new plant. And if the outcome is acceptable, build a new plant. But if the outcome is unacceptable, expand the existing plant. Expand the existing plant. So that is how you go about it in making the decision. We have the EMV now, sorry, not the EMV, the value of information. Although the question had not requested, but it's good you know how it is computed. Value of information. Now, unlike in the single state where we had a very clear formula, this one is not very clear, but very, very simple, because all what you need to do is this. Unarudi hapa kwa hii node ya mwisho. You look at the event, the lines that have gone out. Unachukua the higher, you subtract the next higher. So now that these are just two, unachukua the value tumepata kwa 12, subtract it tumepata kwa 11. It's as simple as that. So that was 24.2. You minus 20.5. I've said you select the highest or the higher, if you are just two, then you subtract the second higher or the next biggest. That is how we get the value of information. Now, I'd like you to read question Question 5 quickly on your own and come up with a sketch. Question 5 quickly. So, any idea? Yes?
First, he has two options.
He has two options. Which one and which one?
Can either sell or extract. When he decides to extract, can either engage the geologist or not engage. On engaging, he can either get the geologist can either get deposit, medium, or flat. Then what can show that.
So do you first of all do something and then go consulting, or you consult first and then do? What do you think is the order?
Consult to avoid loss.
You consult first, good. So if you consult first, this guy has two options. He can decide to consult the expert, that is in other words, do the survey or no survey. Then, when the survey is done, the report can either be bad or good. Whichever report comes out, he has two options. He can either sell or extract. If he sells, he just gets the cash. But if he has not sold and he has decided to extract, he will get the possibilities. The same case here. Then the same applies here. He can either sell or extract. If he sells, that way. If he extracts, so you simply count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 tails. So we have the payoff here. So 1, 2, 3, 4, 5, 6. Nikimeweka gap kubwa. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So this one, we call it number 1. Then here we'll have number 2. Number 3. Have number 4. Is it like that? So this is where we have number 3. Then here we have number 4. Then we have number 5. Then number 6. So this is number 7. This is number 8. This is number 9. Number 10. Number 11. So we are saying here we can go for the survey. And the survey is costing 2.4 million. Or we can decide no survey. And then the report can either come out as bad or good. Now, what the examiner has done is he has given us the various probabilities that make bad and good, but he has not added. So if you add those ones that are under bad, they are how many? Or rather, what is the answer? 0.44 plus 0.05 plus 0.01. So we have 0.5. So the same case happening with good, 0.5. So now, whatever report that comes out, he can decide to sell or to extract. And if he's deciding to extract, and this cost of survey should be brackets, the cost of extraction is 1.6, and it is also in brackets. So here we can decide to sell or extract 1.6. Sell here or extract 1.6. If he sells, he simply gets the cash. If he extracts, he gets nothing, or he gets medium, or he gets what they are calling rat deposits. So here it is cash, there is none, there is medium, there is rat. Then we have cash, none, medium, and Raj. Now the probabilities for cash, because it's just one option, it is 1. But these others, for the deposits, at the bad, we have 0.44, we have 0.05, and 0.01. Then for good, we have 0.26, we have 0.15, and 0.09. Then for these ones that were without the survey, we have 0.7, we have 0.2, and we have 0.1. Now, look here. If you look at these probabilities, you can see they are adding to 1. Because the probabilities that share a starting point must always add to 1. Even this one, you can see they are adding to 1. But for these ones and this one, they're not adding to 1. So what we do, you simply divide each by the total of those 3 or whatever they are. So we are going to divide here by 0.5 so that we get 0.88. You divide this one by 0.5 and that will give you 0.10. You divide here by 0.5 and that will give you 0.02. And they're adding to 1. So you do the same case here. 0.5, you get 0.52, 0.5, you get 0.30, 0.5, you have 0.18. And then the payoffs that are provided is that when you take cash, you have 4 million there. Then if you get none, it is 0. If you get medium deposit, it is 9.6. And then we have 40 here. So this is 4, this is 0, this is 9.6, and 40. This is 4, this is 0, this is 9.6, and 40. So that question, I want to leave it at that point. We shall complete like we have done with the others. So those who are online, have you finished drawing? Okay, Margaret, what about Ivarin? Now on your own, you will attempt the paper, the question of April 2022, question 7B. Question 7B, that's good, Ivarin, I see that. Then November 2020, question 2. November 2020, question 2A. So you do those 3 questions, the one in the past papers, and the one in the handout, and those 2 in the past papers, plus any other that you come across. That past paper. So I want us to proceed now to the next area of discussion, which is called linear programming. Or for those who are online, let me send you the notes. So I've sent the notes on linear programming. Now, linear programming is very, very much related to what we have been doing, decision making. And by definition, as you see in the notes, linear programming is a method that you use to decide which products and how many units of those products will be produced using the scarce resources so that we are able to get maximum benefits. That's all about linear programming. Now, a resource is called scarce if it is not enough. And you know this well from your economics, that the economic resources are never enough. The demand is always higher than supply. So with the little resources that we have, we want to ask ourselves, what can we do so that we get the best return? Which products do we produce and how many units of those products we produce with those scarce resources and end up making the maximum profit. Linear programming is also used in very many other areas. but I don't want to belabor on those because they are not part of your syllabus. Your syllabus will just be looking at the products, which ones, and how many units, and the profit. So those are the ones that are of importance to your syllabus. Now, linear programming is founded on a set of assumptions. And these assumptions, number one is called certainty assumption. Now, certainty, or maybe I discuss as they follow in your notes. The first one is non-negativity. Non-negativity means that we do not have negative values in linear programming, but other forms of linear programming, we have negatives. But for this one, in linear programming, we assume that none of the values is negative. The other one is what we call linearity or proportionality. That means they change in a direct proportion. The values of the resources and the unit and even the profits, they change in a direct proportion, and we'll be seeing that. Then we have what we call certainty. Now, certainty is about the being sure that what we have been told is available, it is what we shall finally get. So there are no values that are changing. So in other words, that tells you we do not have probabilities in linear programming. The other one is finiteness. Finiteness means we are able to know exactly how many items we have, how many units of the product, how many products, how many units of the resources. So it is finite. It is something that you can count. The other thing is additivity. That means you can be able to add the various quantities of the resources that come. You can be able to add the various quantities. And then there is also the issue of divisibility or continuity. It means you can be able to subdivide the resources and be able to get the small proportions. Now we have the steps that are followed, but I don't want to discuss those now. I want to discuss them as I handle a question. Even the format that you can see there for the formulation. And then the other thing is that we have two methods that are used in solving linear programs. The first one is called graph, and the second one is called sequence. So we are going to go through those steps and the methods as we handle a question. It is easier handled that way. So let's go to the past papers. Let's go to the past papers. And we go to this question of April 2022, question 2. No, question 6. Question 6A. So if you look at question 6A, it says, highlight 4 requirements that must be met before linear programming model can be applied. Those requirements are what we have called the assumptions. Those requirements are what we have called the assumptions. Remember, by definition, the other day when you are in testing for reliability, I told you an assumption is a condition. Now, a condition, if I give you a condition, in other words, I'm giving you a requirement that you must satisfy for something to be done. So part B says, or Roman 2 says, a company makes 2 products, 1 and 2. Each product requires time on 2 machines, A and B. The specifications for each product are as follows. So we have product 1 and product 2. We have the processing time, the machine A hours, the machine B hours, the selling price, the material and labor, the maximum possible production in sales units, The maximum time available for machine A is 80 hours and for machine B is 100 hours. Now you are told to formulate a linear programming model to determine the number of products 1 and 2 which should be produced. There should have been number of units. And so in order to maximize total contribution for the, okay. So in step number one is called objective, just like we had in decision making. Step number one is called objective. Now, objective in linear programming, there are two types of objectives. One is called maximization. It is when you want to maximize. The second one is called minimization. You want to minimize something. But for your syllabus, most of the questions you get, they will be about maximization. So just like we were saying the other day in decision making, this is about maximize or maximization of profits. So the objective is to maximize profits. And I told you, when you know it is profit, you need to write the general formula, which is supposed to be revenue minus the costs. Now, when we were in decision making, I told you profit is also known as payoff. But when you come to linear programming, profit is called contribution margin. Profit is called contribution margin. And when we talk about contribution margin, we are talking of price minus variable costs. So when you see profit in linear programming, we are talking of contribution margin, and we are talking of the selling price minus the variable cost. Minus the variable cost. So that is always the first step in linear programming. The second step in linear programming, it is called variables. It is called variables. Now, in the variables, it is where you identify the products. It is where you identify the products that are present in your program. So if you look at the question that we have read, we have two products. There is product A or product 1, and then we also have product 2. Those are the ones we call the variables. You must know which products are present. The next one is you must know what we call the constraints. The constraints. Now, constraints, those are the step number 3, and they are resources in the program. And for them to be called constraint, their quantity available must have been given in the question. The quantity that is available must have been given in the question. So if you look at the question at hand here, we have the machine type for A and B. So we have machine A hours. Machine A hours. And I'm saying the quantity available must be given. You see that is 80. And then we have machine B. Machine B hours. And you can see this is 100. You can see that is 100. So if there is a resource that has not been stated in terms of the quantity available, that does not qualify to be a constraint. Step number 4 is called formulation. Formulation is where now you express. It is where now you connect these profits and these variables and these constraints. You connect them using equations. So, first of all, because this examiner has not given us the contribution margins, we will need to compute. We need to compute. So, tutakuja hapa tuseme contribution margin for product 1. Contribution margin for product 1. You can see the selling price of product 1 is 22 minus The material and labor, we are told it is 14 shillings. The material and labor is 14 shillings. So that tells you the contribution margin is 8 shillings for product 1. Then contribution margin for product 2. The selling price is 48 minus 37. So that gives us 11. That gives us 11. After that, you then, some questions will have computed for you, right? So see here, compute. Then from there, you tell us, let, you can use X to be units of product 1, produced and sold. Produced and sold. Y to be units of product 2, produced and sold. Produced and sold. Then objective function. Objective function. Objective function is written like this. Tumesema we are maximizing, eh? So when inaandikwa maximize z is equals to, you now bring the contribution margin per unit. So this is 8x plus 11y. That is what we call objective function. It shows the profit that will be made. 1 unit is giving us this profit, and we have this number of units. This is giving us this much per unit, and we have this number of units. So when you combine them, you get a total profit. Now this is subject to. This is subject to. You now bring the what? The constraints. So the constraints that are there, we have machine A. Now, as you can see there, machine A requires 1.6x plus in for product Y, it is 1.0y. Now, this one should be less than or equal to 80. This is machine A. That is machine A. Then we have 2.5x plus 1.0y is less than or equal to 100. This is machine B. So those are the only 2 constraints. You can see here, we had just 2. But now, according to one of the assumptions that we had listed, called non-negativity, we are supposed always to say x, y should be greater than or equal to 0. This is called non-negativity. Non-negativity. Then from there, after you formulate, you provide the solution. So the solution using, I've told you we have 2 methods. The first method is called graphical, the other one is called simplex. So using graphical methods. Using graphical methods. Okay, so if you're using the graphical method, the first thing that we do is called coordinates. It's called coordinates. It's called coordinates. So in the coordinates, we start with this equation. 1.6x plus 1y is equal to 80. And this is how you go about it. You put x here and you put y. Then you say, if x is 0, if x is 0 in this equation, what will y be? It is 80 you divide by 1, which is 80. Then if y is 0, what will x be? 80 divided by 1.6. 50. Then you come and do the same thing here for the second one. 2.5x plus 1y is equal to 100. So we have x and we have y. So if x is meant to be 0, y will be what? And if you made y to be 0, x then will be what? 40. Good. So that is how you obtain the coordinates. That's how you obtain the coordinates. Now, from there, the next step after the coordinates is the plot, the graph. Is where now you give us the graph. It's where you give us the graph. And the graph is drawn like this. You can see we have the side of x and y. So the highest y is 100. And the highest x is what? Is 50. So I want us to plot So y-axis, so this is 0. We have 20, 40, 60, 80, and 100. These are units of product Y. Then this one you can have 10, 20, 30, 40, 50. This is x-axis. These are units of product 1. No, this one now I should have said product 2. We are through at that point. So you now plot. When x is 0, y is 80 here. And when y is 0, x is 50. So you connect them this way. And you label that this is 1.6x plus 1y is equal to 80. Then you brought this other one, 100 and 40 here. Then this line is 2.5x plus 1y is equals to 100. And these corners, these ones, I want us to label them. This one you call it C, this one you call it D, this one you call it E, this one you call it G, and this one you call it H. You label them that way. Now the labeling is not a must label, but now that I'm teaching you for the first time in graphs, it's good I label so that you're able to follow consistently. And in the labeling, you can use any letters, but you should avoid any letter that is already in use in our program so far. You can see we already have A and B. A and B. Yeah, we have A and B. That's why I've started from C. Yeah? Yeah. Now, this one, you see they are saying less than. So if they are saying less than, it means we want the lower side. So you shade the upper side. For these two lines, and this region here is called feasible region. Feasible region. Now, feasible region is the region where we have the solutions. So the solutions are found in the corners. So it is either this corner, or this one, or this one. Now, this corner H and corner C do not apply as far as the solution is concerned, because they are not corners of the feasible region. So the corners of the feasible region is this one, and this one. So one of them or several are the solutions. Now, the one which is the solution is the one which is farthest from the origin. So you can test by observation. Katia D, E, and G. Which one is farthest from the origin? If you are not able to see which one is which, we test the corners. We test the corners. First of all, for the coordinates here, we have for D, this one you can read. See, this one tunaona ni 0, 80. Na hii tunaona ni 40, 0. But sasa hii, we are not able to read correctly from the graph. If you are not able to read correctly from the graph, what you do, you solve the equations simultaneously. So obtaining coordinates for E, obtaining coordinates for E, you solve those equations in a simultaneous way. The equations that make that corner. That is 2.5 E plus 1Y is 100. And then 1.6X plus 1Y is 80. So sasa, when you subtract, this will be 0.9X is equals to 20. So solve and tell me X is what? Huh? 22.22. So we can retain it at 22. Can make it 22. Then when you come to Y, then utasema 2.5 times 22 plus Y is equals to 100. So tell me Y will be what? Yes? 45. So because we are not in a position to tell which of the corners is farthest, nimekwambia you test each these ones. So sasa tutakuja hapa tuseme testing the corners. Testing corners of the feasible region. of the feasible region. Testing corners of the feasible region. So in this testing, we have it like this. We have the corner and then the profit. We have the corner and the profit. We have three corners that we are testing. We have corner D, we have corner E, and we have corner F. So for corner D, the coordinates of corner D, X is 0. Now that 0 you multiply by the profit. Huwa tunaweka kwa hii equation ya ama ningeiweka, let me put it this way so that you are able to easily connect. 8 times 0 plus 11 times at corner D, y is what? 80. So do that. 880. Then 20 kwa corner E. It is E, or rather 8 times X happened in 22. Plus 11 times Y there in 45. $671. F, F ni G, it's corner G. So G, X is 40, so it is 8 times 40 plus 11 times 0. $320. That is how the corners are tested. So the optimal solution when you're told to tell us optimal solution, there are two things that you tell us. One is about production. One is about production. Now, production, you tell us which product we are going to produce. So we had product 1, which was represented by X. And obviously, as I had said, linear programming is supposed to help us get the maximum profits. So this is the one that is maximum. That 880 is the maximum. So at that, X is 0 units. For product 2, we have Y, which is 80 units. The second item that you should give us is profit. And profit, you should give us the maximum. And the maximum that we are getting is shillings 880. That is how you solve linear programming using the graphical method. Is that okay? Margaret and Evelyn, are we okay with that? Yes, Evelyn. Yes, Margaret. Good. Higher. Let us go to this one that was tested in November 2019. Go to November 2019. November 2019, I think is question 5B. So the question says, a manufacturing firm produces two products, X and Y. The standard revenues and costs per unit of the product are as follows. So we are given the selling price, the variable cost of material B, direct labor, packing, other variables, fixed overhead, standard profit. Packaging is a separate automated product task, and the cost relates to materials and electricity. The maximum available inputs per week are limited as follows. So we are given that the profit of the company could be increased by increasing the selling price. Now formulate and solve the above using graphical method. So as we have said, the first thing is always to know the objective. The first thing is to know the objective. And I've told you in your questions, and as you can see here, it is about the profits. So it is to maximize profits. Maximize profit. And we have said profit is the contribution margin. Is the contribution margin. And this contribution margin, tumesema it is the price you minus the variable costs. It is the price you minus the variable cost. Then we have the variables. So the variables, tumesema they are the products. So as you can see here, we have two products. We have product X and we have product Y. Product X and product Y. The next thing is constraints. And when it comes to constraints, I've told you they are the resources, and they are the resources whose quantities have been given. So the first one is material B. Material B is 240. Then there is rubber, which is 200. Then we have packaging, which is 100. You can see that, eh? Okay. So if you have that, then we go to formulation. But then we solve matrices. So formulation, let's first of all compute the contribution margin of product X. Contribution margin of product X, it is the selling price of 400. You minus the variable cost. You can see the variable cost when they are added together, they are going to be 20. So that gives you 80. Contribution margin of Y, it is 360. When they are added together, the variable cost is 300. So the contribution margin is 60. So with that, now you say, let X to be units of product X produced and sold. Produced and sold. Y to be units of product Y produced and sold. Produced and sold. Okay. Produced and sold. Then objective function is to maximize Z. Which is 80x plus 60y. That is the objective function. Then there's a subject 2. Subject 2. If you look at material B, you can see 1 kg now is what 24. Can you see that? So if product A gonna cost ya 80, kumaanisha ilikuwa na 4 kilos. So 4x, the same case with B. 4y, I mean with y, should be less than or equal to 240. That is for material B. Let's go to direct labor. If you look at direct labor, you can see 1 hour in 16 shillings. So product A, rather product X, is equal to 64. 64 divided by 16 is what? So it is 4x plus hii ingine itakuwa 2y is less than or equal to 200. Is less than or equal to 200. Haya, tukikuja kwa packaging, you can see 1 hour inalipwa 24. So 24 divided by 24, that is 1, eh? So 1x plus 2y is less than or equal to 100. And I've told you, we should always put x, y greater than or equal to 0. That is the step of formulation. After you have formulated, you now proceed and give a solution using graphical methods. Solution using graphical method. That is what the examiner has suggested. Solution using graphical method. I've told you the first thing with the graphs, the first thing is to do the coordinates. Is to get the coordinates. So we are going to have this equation 4x plus 4y being equal to 240. So we have something like this. This is x, this is y. So tell me, if we made x to be 0 there, y will be what? 60. And if we made y to be 0, it will also be 60. So 4x plus 2y is equal to 200. So if x is 0, y is what? 100. And if y is 0, x is what? 50. So then we go to 1x plus 2y is equals to 100. So if x is 0, y is 50, and if y is 0, x must be 100. So we now brought the graph. We do the graph. So as you can see, the highest again is 100 for x and y. So we can have so this is 20, this is 40, 60, 80, 100. This is x-axis, and this is 0 here. So these are units of product x. So this is 20, this is 40, this is 60, this is 80, this is 100, and this is y-axis. So these are units of product Y. Units of product Y. So if those are units of product Y, let's plot 60, 60. 60, 60 hapa. This is 4x plus 4y is equal to 40. That is 60, 60. Huyu mwingine y ikiwa 100, x is 50. So 50 kulingana na hii graph yangu iko hapa. So sasa hii naweka na hii. So this is 4x plus 2y is equals to 200. Then huyu mwingine 50 and 100. So this is x plus 2y is equals to 100. So you shade these sides this way. So sasa hii is our feasible region. This is our feasible region. At this region, as you can see, it has 4 corners. This one I can call it, we don't have A so far, but we have B. So this one we can call it C. This one we call it D. And this one we call it E. So let's now test the corners. Testing the corners. Hii unaweka below the graph. It is supposed to be below the graph. Siweke mahali na kuwekelea. So testing the corners of feasible region. So we have the corner. The other one is how to make a coordinates. For those zinakuja is more repetition. Hii ni repetition. But there are some people who can keep on asking, where did you get those ones? So then we have the profit. So let's start with corner A. Do you know the coordinates of corner A? It is 0, 50. It is 0, 50. X is 0, y is 50. Sasa hizo coordinate ndio nimekwambia you substitute in the objective function E, which was 80x, so it will be 80 times 0 plus 60y, 60 times 50. Yes, 3,000 or 300. Thousand. Let's go to corner C. Sijui kama kwa your graph nasomeka yangu hapo ni 20 na hapa inaingia 40. Nasomeka vizuri, si ndio? 2040. So kama ni 2040, this is 80 multiplied by 20 plus 60 multiplied by 40. Yes? 4,000. We have D. So D, hata inaingia vizuri sana. Swali inakuwa vizuri sana. Is 40, 20. So it is 80 times 40 plus 60 times 20. $4,400. Then we go to corner E. The coordinates are 50, 0. So 80 times 50 plus 60 times 0. So is that 4,000? Yeah. So you pick the highest of those. So the highest is E. So the optimal corner is corner D. So with that now, you come and tell us the optimal solution. Optimal solution. So optimal solution, I've told you it has two things. One, you should tell us production. You should tell us production. And as you can see here, we have product Y, or rather product X, which was represented by small x. And at this point, X is 40. 40 units. Then we have product Y. We have product Y. And product Y at that point, it is 20 units. Then you tell us the profit. That's the next item. And this profit, you are telling us the maximum. So the maximum is shillings, 4,400. 4,400. So see, we are okay with that. So you can try this one of September 2015. September 2015, question 3A. So you try that. Now, as I said, we are meeting now on Monday. Tomorrow we will not have a class as we had suggested, but that class we can push it to next week Saturday. Thank you.